everybody! So you've decided to expose yourself more to technology. Where exactly do you begin? I would say learning a programming language is definitely worth it. Coding can help us to develop our resilience dealing with challenges. The ability to solve problems would be useful even in our normal life. It teaches us how to think, and as you can read in my channel description, it is the future. One way people start learning to code is by picking a programming language and jumping in head first with no direction. The other way is learning with a roadmap. And I'm gonna propose a roadmap I wish I had when I started learning to code. This is the coding essentials. Of course, knowing them will not make you an expert programmer, but makes you aware that each one of these topics exists and hopefully give you a bird's eye view of the coding world so you can build on it intelligently going forward. Coding is a technical form of communication that computers and not humans are meant to understand. Thankfully, modern programming languages enable us to create applications without worrying about the details of the hardware behind the scenes. However, that doesn't mean it's useless to know the basics of the device that your code is executing on. So let's begin with the bare minimum of computer architecture fundamentals. Your computer's most important parts live on microchips. Microchips rely on a component called a transistor. Transistors are tiny electrical switches that are either off or on at any given time. A single microchip can contain millions or billions of tiny transistors embedded on it. Most computers have a microchip called CPU. You can think of it as the computer's brain. It handles the number crunching and logical tasks that the computer performs. Each CPU has an instruction set, which is a collection of binary commands that the CPU understands. Luckily, we don't really need to worry about that as software developers. If the CPU is the logical center of the brain, computers have RAM as working memory. It keeps information temporarily that is actively being used by running programs. RAM is made up of a collection of memory addresses, which can be used to store bits of data. Finally, you're surely familiar with the hard drive. In our analogy of the brain, this represents long-term memory. A hard drive is an internal or external device that stores data that should be persist even after the computer is turned off. But what exactly do we mean by the word data? At a high level, we think of things like documents, images, videos, emails, files, and folders. These are all high-level data structures that we create and save on our computers every day. But underneath the hood, a computer chip like a CPU or RAM has no idea what an image or a video is. From a chip's perspective, all of these structures are stored as the sequences of ones and zeros. These ones and zeros are called bits. Bits are stored in a set of 8 at a time known as a byte. So a byte is simply a sequence of 8 bits. We use our coding skills to tell the CPU what to do by stringing the sequences of ones and zeros together in a form the CPU understands. So stay tuned. In the next video, we'll talk about how programming languages work and provide a means of bridging the gap between the way human brains understand the world and the way computer brains or CPUs understand the world. Thank you so much for watching. I'll see you soon.